All right, today we got the combo lesson working. We've got our law of sines and cosines trig packet, but I'm going to kind of do this in reverse order. So we're going to flip to the back of this packet where you'll find your preview for quiz 1. And we're going to chat a little bit about how we can do some of these things. Now again, this is basic of basic with right triangle trig, and I said it was going to basically be that for this first quiz that we've got. So it is as simple as I have an angle, which sides do I have? Well, I have opposite and hypotenuse. So what's that mean? I use sine. So the sine of 52 equals opposite over hypotenuse. If I work through solving this for x, which is what I would do anyway, I do 40 times the sine of 52. Now again, make sure your calculator is in degree mode. Degree mode, we're good. And then it's pretty straightforward. And I'm set. Okay, so don't overthink this first part, especially with all the laws that we've been doing lately. Same thing here. I've got adjacent and hypotenuse, which tells me I'm going to be dealing with cosine. Now remember, we talked before about how if x is on the bottom, when x is on the top, we multiply the value times our trig function. When the x is on the bottom, we divide. So my x value is going to be 85 divided by the cosine of 37. Because once I algebraically multiplied both sides by x and then divided, that's what I'd end up with. So probably would help if I put the division sign in, though. Excuse me. And get my value. And I'm just going to keep running through these. Okay, opposite and adjacent, which is tangent. Again, here, my x value is up top, so I'm going to go ahead and multiply. Times the tangent, 27. And then finally, swing over here, I'm looking for an angle opposite hypotenuse, which is sine, but remember, and that's why I'm going to use the -1 here. For this one, I have to do second and sine since I'm looking for an angle, and then type my fraction in. And get that value. Okay, so as I move down, get into an app here. Building casts a shadow of 46 meters. Again, when we have shadows, once you get over the fact that my right triangle doesn't look very right, the shadow is going to be based on the ground. Okay, not up here. When you look at it, you see it on the concrete or the pavement or the grass, whatever it happens to be. And the angle of elevation would be as it looks up from the ground. Okay, how tall is the building? So just like I have up top, now that I have a picture, I have opposite and adjacent, which tells me I'm going to be using tangent. And again, since my x is on top, I'm going to end up multiplying. So pop our calculator back up here. So the building's about 21.5 meters tall. So we get that part situated. Then we move on. And we have some triangles. Notice they're not right anymore, so we're going to have to deal with our laws some. And I start to look to see, what values do I have and what can I do? So I like to go ahead and label these. You can use them A, B, C, wherever you'd like, as long as we get the other portions in here. And again, sides are opposite Now, before you get going here and say, ooh, two angles and a non-corresponding side, I'm going to use law of cosine. I'm trying to give you a hint right here. With the fractions, you can use law of sines. But you're like, well, wait a minute, how am I going to use the law of sines? I don't have a corresponding side and angle, or do I? Again, add these two up. A triangle adds up to 180. And I actually know what angle B is. And now I do have that corresponding side and angle. So I can go ahead and use the law of sines. And since we're looking for the length of side A, use that. Excuse me. Oh, and then I flipped those. Oh, Harty. I'll rewrite that. My apologies right there. So when I go through here and work for my proportion, I'm going to have 23 times the sine of 39. Again, my diagonal that does not have the variable term, divided by the sine of 73. So my A value is 15.1. Okay, so always take a look at your info first before you dive too far in. Second one, I didn't make you think as much. Corresponding side and angle given to you right away. Find the measure of angle B. I know the side. And again, measures are when we use the -1, the second function. So we've got 7 times the sine of 27 divided by 12. But remember, and this will be a little more obvious when you actually get into it, if you do happen to forget, that wouldn't make much sense as an angle. So again, here I do second sine. There again is my -1. Why I write it to remind me of this. And I plug in that decimal. And I find out B is about 15.4 degrees. So again, hint, use law of sines. And again, that's on your goldenrod sheet. So there's no reason really not to have that. Okay, so then I get down to number 9. And I go, okay, use the law of cosines. I'm even going to be nice and tell you. So I get ABC. I go ahead, I jot down what I know. And again, I see I have two sides and a non-corresponding angle. So I'd have to use law of cosines whether I wanted to or not. So to find C squared, I just follow my formula sheet. So the sum of my two side squares minus 2 times their product times the cosine of that angle. And again, unlike the one when I'm looking for the side, I don't have to be too worried about my order as I do this. I'm just basically going to type it in, except I need to make sure I type it in correctly. But again, that's my squared term. Okay, that's what C squared equals. I want to know what side C is. So if I take the square root of that value, I get my C value. Okay? And then this last one that's here, and then we'll talk a little bit more about the quiz itself for a second. Here I've got all my sides. Now we talked yesterday about here I have an option. Because when I'm doing my law of cosines, how we also have this option of using the fraction, which basically is just we algebraically manipulated it to get cosine and a side by itself. So if I choose to go that direction, Or I could use the equation again, but we talked about how I got to be careful with it. If I go this route, so here I'd use a and b squared minus c squared, again in parentheses, don't get careless, over 2 times a times b. Again, I just manipulated and realized when I was looking at my golden sheet, okay, the a here was used here and it wasn't used at all in the denominator. That's where my b and c was. So I just basically switched around since I was looking for c. I traded off the c and the a values, okay, and went at it that way. So now that I've done that, and my screen is coming back to normal, go ahead, get that typed in. Again, I can't stress enough the need to have the parentheses there or this will not work out well. Even on the denominator, and I need to show that on mine too so we don't get confused later. And again, we're looking for an angle, so second cosine and my value. Okay, now, before some of you go, woo, this is going to be simple, 10 questions, da-da-da-da-da. Let me give you an exact breakdown of what your quiz tomorrow is going to look like. You're going to have 4 problems, like the very top with 1 through 4, where you're finding a side or an angle. Okay, you're going to have 3 applications, like you had number 5, where you're going to either have a picture or draw a picture and do an application. You're going to find the area of a triangle given information, but again, that's right on your goldenrod sheet here, so that shouldn't be too big of a deal. 3 problems with law of sines, 1 application. 3 problems law of cosines, 1 application. So you'll notice, that's 15 problems, not 10, but I will tell you in advance before we get into some of the packet problems, the law of sine and cosine apps will not be as bad as the ones in the packet, but I want to challenge you a little bit. We're going to talk about that here in just a second. But if you've done any of the homework and practiced this at all, especially if you've been using your golden sheet, this will be easy peasy, okay? All right. Now, back to the front. For the rest of the time on this, I'm going to kind of pick and choose some of the different problems that are in here to discuss a bit with you how to set them up, how to do them, and then the rest of them you'll need to deal with, okay? And also pay attention to the board because there's a little bit of a note up there for you on extension of the homework check this time. Okay, so let's start up here at number 1. We'll bounce around a little bit. Alice kicks the soccer ball towards a wall. The ball is deflected off the wall at an angle of 40 degrees and it travels 6 meters. How far is the soccer ball from the wall when it stops rolling? So, here's the wall. There's the ball. How far away is it? I mean, I even could use right triangle trig to be perfectly honest on this, but since we're using law of cosines and cosines, I'll go ahead and attempt to do that here. So you're like, okay, how would you do that if you're not going to use right triangle? Well, I've got an angle on its corresponding side. You're like, but all I got left is the 6. Yeah, and its angle. Excuse me, sine of 90. So I go ahead, I cross multiply, I divide to find my x. Shift this over a little bit. And I find out that it's about a little less than 4 meters away. So that's one thing we've got kind of working here. If we skip down a little bit further to 3. Okay, no picture, so we're going to have to get creative here. Sarah Phillips, an officer for the Department of Fisheries and Wildlife, checks boaters on a lake to make sure they do not disturb 2 osprey nesting sites. She leaves a dock and heads due north in her boat. Okay, I'm going to start drawing a picture here. Okay, she leaves this dock and heads due north, so she heads upward in her boat to the first nesting site. Okay, so here's nest 1. Okay. From here, she turns 5 degrees north of due west. In other words, instead of just going straight to the left, she's going to go up a little bit. And travels an additional 2.14 miles to the second nesting site. She then travels 6.7 miles back to the dock. How far from the dock is her first nesting site? So I start to look and see what I have. Now, here's the part that gets a little bit interesting. I actually have an angle measure to work with here. Because you're like, I don't have all 3 sides, I don't have an angle. Oh, but I do. So, what we're going to do instead, if you're going north and then turn left, I'd make a 90-degree angle here. But I went 5 degrees up further than that. So I actually know that this is 95 degrees. So now, based on that information, I have a corresponding side and angle. And now I go through and I'm like, okay, gosh, what else can I do with this? Well, since I can't get directly to what I'm looking for, because I don't know this angle yet, I do have this bit of information though. So I can find that angle. This is going to take me more than one step. So I get that set and I go, all right, cross multiply my other side. Divide by the 6.7. So I start to work through this. And I'm like, all right, 2.14 sine of 95 divided by 6.7. Oh yeah, this is an angle. So I got to do second sine. And of course, this is going to be, this is going to be the time when Harty gets some weird stuff going on. Okay, let's try this again. You always know stuff like this has to happen when you're trying to get stuff done. Second sine. There we go, that's better. Okay. So D is 18.6 degrees. So I plug that in. And that's actually going to make my life easier to finish this off. Because now I can take these two guys. To get my other angle, I can add these two up and subtract from 180. So that gives me 66.4 degrees in that other one, and now I've got all my corresponding parts. Now I can take that sine of 95 over 6.7 that I started with, and now I have the angle measure for my mystery, but I don't have this part. So this is definitely a process that you have to work through as you're dealing with this stuff. It's not just going to be a quick slam it down there, solve it, and say it's good. And I find out that x is 6.2 miles, and I'm set. So again, we can run some challenge here. We just got to work through it a bit. We're also going to do 4. You're like, dang, you're going to do this whole packet for us? No, I'm not going to be that nice. I've got a couple more here we're going to do, though. Then I'm going to make you ponder for a bit. Okay, number 4. Rock climbing. Rock climber is part way up a climb when he can see both the peak and the base of the Great Mountain. When viewing the peak, his angle of elevation is 42. When viewing the base of the mountain, his angle of depression is 36. If he knows Great Mountain is 2,000 feet high and the base of the mountain is at sea level, then what is the elevation of the climber to the nearest foot? Okay, so here's our little climber guy. He can look up and it's a 42-degree angle. From where he's at, he can look down, and it's a 36-degree angle. So once I know that, okay, he knows Gray Mountain is 2,000 feet high, so top to bottom. So this entire side would be 2,000. And again, they make right angles with it. What is the elevation of the climber to the nearest foot? So if this is the base down here, and this is the top up here, how far up is this guy? In other words, how far is it from the base over to here? Or is it like, oh, Harty, why you gotta mess with us on this stuff? That's not how I tell distance. I tell distance this way. So we're trying to figure this out. Now, how hard or easy is that going to be? Well, let's fill in some other information that we can. Here I've got 2 of the 3 angles for both of these triangles, so it's not going to be incredibly difficult for me excuse me, to go ahead and get those values plugged in. Once I get those plugged in, now the challenge begins on figuring out the pieces that I have and what I want to find. So, to me, as I do this, I kind of start to look and I'm like, I don't have an idea on how I can actually do this. So I'm like, well, I got this and I got an angle, but I don't have another side to deal with, but I got this side. Okay, here's what I have to do. I've got to look at these as separate triangles. I've got this really big triangle along the outside. And what do I know from that? Well, I know that I have this side, and I have the angle opposite that side, this 42 and 36, which is the sine of 78. Okay, I'm going to zoom in a little bit here to try and make this a little bit easier for you to see. So then I look, and I'm like, okay, well, what else would I know? I don't know. Well, let's try to work on getting some stuff for this triangle so I've got another side to work with. So if I do that, I've got the sine of 48, and I guess we'll call this y, side opposite the angle. So I go ahead, I type all this stuff in my calculator, my 2,000 times the sine of 48, and then we're going to divide by the sine of 78. So y is about 1519.5 feet. Okay, so 1519.5. So then I'm like, okay, now I think I can actually get to the x value that I'm looking for. Like, dang, sometimes this gets complex. Again, that's why the people who come up with all this stuff make the big bucks, because this isn't an easy thing to deal with. So I look at this last part, and I'm like, okay, so the sine of 36 is to x, angle, side, as, what's my other comparison that I can make? We basically have a situation like we did up in number 1. I've got this other side, 1519.5, but what angle is opposite that? The 90 is. So sine of 90. And I do my same that I have been. Multiply the two together. And then divide by whatever's with my x, which in this case is the sine of 90. And I find out that x, he's up about a little over 893 feet. But again, I really had to take my time through that, trying to read it, trying to see how all this stuff works to make sure I had it on the right track. And I think I've got, is it 2 more here that I've marked? It is. So I got 2 more I'm going to do with you. So we're going to have a pretty good chunk of this done together. We are going to jump up to number 7. Probably should get the calculator out of the way. All right, cameras. Security camera is located at the top of a building a certain distance from the sidewalk. The camera revolves counterclockwise at a steady rate of 1 revolution per minute. In other words, it goes 360 degrees. At one point in the revolution, it directly faces a point on the sidewalk that is 20 meters from the camera. 4 seconds later, it directly faces a point 10 meters down the sidewalk. I think we're going to have to draw some pictures here. How many degrees does the camera rotate in 4 seconds? Now, when we talk about the word revolution, again, it means going in a circle, which is 360 degrees. So, if we can do 360 degrees per minute, how many seconds are in a minute? 60. Means I go 6 degrees per second times 4 seconds. Means I'd be going 24 degrees in 4 seconds. You're like, what's that got to do with any laws? That part doesn't. However, it does get us to a portion now where we might be able to get some information to draw this second part. So let's go back to the problem again. So at one point in the revolution, it directly faces a point on the sidewalk that is 20 meters from the camera. Okay. So I got my building. Hopefully it's at a right angle to the ground. Otherwise we're going to have some trouble here. Okay, so the camera's facing 20 meters away. Then, 4 seconds later, it's facing a point that's only 10 meters away. So now I got some issues brewing here. So I'm looking and I'm going, okay, how's this work? Okay, let's go back and kind of look. It said, at one point in the revolution, it faces a point that's 20 meters from the camera. So here's where my part from part A comes in handy. At one point, it's 20 meters from. 4 seconds later, or 24 degrees later, no, it's not time to go. So I start to look at this and I go, okay, where am I actually going to be able to find a value that is going to help me with this? And all of a sudden it appears to me, ooh, I have 2 sides and a corresponding angle in this little triangle out here. So I could locate this value. Okay, now it doesn't help me completely quite yet, but it gets me a part towards where I want to be. So I look and I go, okay, so this is kind of my part 1 here. Let's see if I can squeeze all this in. So to find x squared, I'm going to take the sum of the squares of my 2 sides minus 2 times their product times the cosine of 24 degrees. To kind of help you out a bit here so we can get to more problems and stuff, I've done all the math already. So my x value is 11.6. So I get that jotted down. And I go, okay, I'm not quite where I want to get yet, because what I'm actually trying to do is figure out what's going on in here when it's 4 seconds through. So I look and I go, okay, what is my next piece that I have? Well, now I have a corresponding side and angle. So now we can go to the law of sines. And I notice I have a side and I could find this angle. And you're like, really? I got to go find something else that I don't want yet? Sometimes it's going to take a little bit of time to get to the spot that we need. So I get that typed in. 20 times the sine of 24. Divide by 11.6. Remember, it's second sine. So I get my angle C, which is 44.5 degrees. And you're starting to roll your eyes at this point, probably. Some of you are probably flipping around, looking at some crazy game on your phone at this point. But for those of you that aren't, we're getting there. We got to squeeze a little more out of this. If we got to roll up into this area up here, we can. So I look at that and I go, okay, I'm still trying to get over to here. This is starting to drive me nuts. I got a corresponding side and angle. If I could just get an angle or a side, I'd have this. But wait, I can. This makes a straight angle. How many degrees are in a straight angle? 180. So 180 minus the 44.5 gives me this angle right here. And now we're in business. Because the last and final part, you're like, good Lord, it's been a whole worksheet just on one problem, is going to be the sine of 135.5 is to x as the sine of 90 is to 10. So let's check this out and see what we finally have gotten ourselves into here. And we find out that it's about 7 meters. Now again, I'm going to keep stressing this. These are extreme examples, not the type that you're going to see on a quiz test. I may put something similar where a picture's drawn or something. You have to figure some things out, but these are, again, more of a challenge. So when I'm looking at a homework check, I'm looking to see if these have been honestly given a shot on an attempt. Okay? Not that everything's perfect, but that you've actually given it a try. Okay, last one I'm playing with. Number 10. All right, the figure below shows a map of some buildings in Aiden's hometown. The sine of the angle theta formed by the high school, the middle school, and Aiden's house is 3/7. Now, that tells me something. The sine of the angle. Opposite over hypotenuse. Which tells me I can figure out what the adjacent side is by using the Pythagorean theorem. Excuse me. Because when we start to look at this, 3 squared plus x squared, 7 squared, is going to be 2 times the square root of 10. So you're like, okay, I can kind of see how this all works. So once I get that, now I can kind of go back through and build some of these things. Okay? Cosine of the angle. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Nothing too complicated to have to deal with. So I keep going with this. It's the tangent. Opposite over adjacent. Ooh, issue this time. Issue being I can't have a radical in the denominator. I need to rationalize it. So I multiply just by the radical. I don't have to multiply by the 2 as well. Not a big deal there. Square root of 10 times square root of 10 basically just eliminates the radical, but 10 times 10 is 100. The square root of 100 is 10. So 2 times 10 is 20, and we're set. And again, we're starting to go into all those same questions on C, so I'll be nice and just whack them. Okay? Again, just give these a legit shot. I will be happy with that. Okay? And if we need to talk some of them on Friday, we can, but you'll just have basically the types of story problems on your quiz that are more like the ones from the homework and the notes that aren't quite as complex as these, where I'll either give you a picture or make a real simple drawing out of that. All right, see you then.